Okay, good evening. I think now you can mark attendance. Yeah, for the PT, yeah. Yep, group by group. Now start with PT first. Okay, now PT 20. Okay, now ODM. Yeah. Okay. So anyone who joined a bit late, you can let me know in the chat box. Okay, so as usual, yeah. So okay. Okay. So it's okay. Um, you can vote until 7:30. Yeah, but for today we cannot change. Yeah, we start 7 until 7:30, take a break, and then start 8 until 9:30. Okay. But now you can vote now. Yeah, you can start voting now. Start. Okay, wait. I also follow the majority. I'm okay. Yeah, I'm flexible. Yeah. So yeah. So you just like the message. Okay, this is until 7:30. Yeah. Yeah. So 7:30 until 9:30 or follow schedule. Yeah. Okay. Okay. So now is okay. We are okay. So now we see for the previous discussion, we are still in chapter 2. Of course, finishing. Yeah, we can finish the topic today. Yeah. Okay. So for the previous discussion, any question you want to ask? Yeah, since we are still in the multiple linear regression. Okay, so okay, actually not only the multi-coordinality, yeah, it's every all the testing that we discussed in this class, all the testing, yeah. Okay, you see this assignment, oh yeah, this is tutorial, yeah. Yeah. So for assignment, I also already uploaded to the model, yeah, just now. Okay, just now. So okay, it's looking part three, yeah, part three. Yeah. So okay. So it's just testing all the testing that we discussed in the class. Okay. Yeah. Okay. So we see. Wow. Okay. Okay, I think so far 7:30 majority. But anyhow, today we follow the schedule. If 7:30 really majority, then we start tomorrow. We follow the 7:30. Okay. Okay. So we continue with our discussion now. Yeah. So we are here. Yeah. Okay. So we need to interpret the result. Yeah. The regression variable once you done. Yeah. You done the output. So interpret the impact of each independent variable relative to the other variables in the model. Yeah. So okay, means you do some comparison. You have to see which one is significant, which one not significant. Which one reject the null hypothesis, which one you cannot reject the null hypothesis. Okay. So sometimes you need to read specification, yeah, your model. Yeah, sometimes. Yeah. Let's say model not too good, result not too good. You may need to re-specify your model. Okay. So then we see the difference between the beta and also the this is actually okay. So therefore be careful. I've got two beta. Yeah, one is the standardized, one is the unstandardized. Yeah, which also one student asked me in the class previously. Yeah, so we use the standardized beta. Okay, yeah, for us to test the relative importance among the independent variables. Okay, so this is the beta, the standardized beta. Okay. So okay. And then the regression coefficient describe the changes in the dependent variable. It's okay. We discuss again how to interpret the beta coefficient of the independent variables. Okay. So y equals to, let's say alpha plus beta 1. Okay, now you can discuss a little bit more, but I think already discussed in the previous class. It's okay. Let's say the final result. Okay. So let's say the final result, okay, let's say 3, yeah, 2.5 x1, yeah, beta 2, let's say, it's okay, beta 2 not important, yeah, so not important, okay, like this, yeah. Now we see how to interpret 2.5, yeah, maybe discussed already, but it's okay, yeah. How to interpret 2.5, yeah, okay. Okay, when the x1 increase by sorry, okay, by 1 unit, yeah, then the y, yeah, the y will increase by 2.5, yeah, 2.5 unit. Okay, so for the other variables, constant. Okay, so the list already very good. You must put this term, this three words. So because here you consider the beta 2 x2, I mean beta 2 x2 is in the model. This is multiple linear regression. So therefore you must, it's when you interpret the x1, actually you hold other variables constant. Okay, so this is the how to interpret the beta.
So this beta coefficient, just now as you said, it should be a standardized beta coefficient, right, rather than unstandardized.
Unstandardized.
This is unstandardized.
Yeah, correct.
But we can.
Yeah, because we use the unstandardized coefficient, you have to what do you call to interpret. Unstandardized, they follow the actual unit. Okay, now the actual unit. Example, let's say a kilogram or ringgit and so on and so forth. But standardized are no unit. These are free from unit.
Also, if we mention like increase by 1 unit, then the other dependent will increase by 2.5. Then this is unstandardized. So if standardized, then we will mention the unit, and I mention like a kg or ringgit, something like that.
No. Unstandardized here. Okay. I think I make it this. Let's say one. Okay. Example. This example. Okay, 1 kilogram. Yeah. So here is 2.5. Can you see? Something like that. Can you see? Yeah.
This is
This
standardized.
is unstandardized. We never use the standardized beta for the interpretation. Never.
Okay.
Yeah. So the unstandardized is only for us to compare the relative importance of the independent variable. Okay.
Okay.
So if no problem, now we see next. Okay. So now we are here. Yeah. Okay. So therefore, the analysis done, but can be difficult in comparing across. Okay, therefore, we did not use the unstandardized, okay, to interpret. Yeah, but we use the standardized here to compare. Yeah, for different function, we demonstrate each one more important. Yeah, actually we both important, but different function. Okay.
Sorry, sir, just to make it clear, we use the unstandardized to interpret or standardized to interpret.
Okay. You can see?
Heard something different.
Here is unstandardized. Here
Okay.
all is unstandardized.
Okay.
Yeah. Standardized is for us to compare each one more important. Yes, correct. Can you see? So you see each variable is more important. Yeah, therefore we use the standardized.
Or which independent is more important, we use standardized. Okay.
But to interpret the equation, use the unstandardized.
There's between the IV and the DV.
Yes, correct.
Okay.
No question. Now we see next. Yeah. So anyone just join? Let me know. Okay. If no, miss, we continue with the discussion. Yeah. So we are here. Okay. So multi-cardinality normally no good Okay. Actually I mean there's always there. The problem of multi-cardinality always there. But just that if the VIF is below 10, means still consider okay. We can accept. Yeah. But more than 10 is a problem. Right. So it's like this. Yeah. Okay, so therefore, here they mention in generally it's viewed as a harmful since the increase in the multi-cardinality. Okay. So this one discussed already. Now a bit more. They will reduce the overall R square. Yeah, that can be achieved. Yeah. So, but even but the effect on the R square not much. The problem is on the the regression coefficient, which is a t. Okay, so the t will drop. Okay. Okay. So therefore, they will confuse us. Yeah, they will confuse us. They say suppose positive, but because of the problem, therefore become negative. Okay. So negatively affect the statistical significant test of the coefficient. Here also same thing, refer to the t test. Okay. So means what? Means we still can rely on the R square, but not the t. Yeah. Okay. Of course, let's say we have f or below 10 is very good, but in case more than 10, therefore don't trust on the t, but R square still okay. 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 No problem.
So what meant by suppressor effect?
It's a it's okay, but ignore this, don't worry, ignore this. In generally, it's negative. Yeah. Okay. It's a little bit positive, still okay, but you can see here, in generally, it's more negative. It's harmful. Yeah. Ignore that one. Don't worry.
Okay.
Okay. Because it's clearly means this you can see this way. The benefit is very minimum, but the what they call, but the negative impact is quite a lot. Therefore, not too good. Yeah. Okay. So we see. Yeah. So we generally accepted the level of multicollinearity actually is 10. We have 10. Okay. So you can also use tolerance, which is up to 0.1. Means it's less than 0.1, still okay. Yeah. Tolerance less than 0.1, still okay. Yeah. But actually same thing, same thing. Okay. Discussed already. VIF is equals to 1 minus 1 over tolerance. Therefore, same thing, yeah. Okay. So almost always indicate problem with the multicollinearity. Yeah, okay. So as I mentioned just now, it's always there, almost always there. Right? But the problem may be seen as much lower level, yeah, of the collinearity, yeah, or multicollinearity. Yeah. So the means they say we are 8 below 10, still okay. Like that. You see a bit more, yeah. Okay. So bivariate correlation, meaning that the correlation between the two variables. Okay, this also discussed already in stat, okay, by your stat lecturer. Okay. So bivariate correlation of 0.7 or higher may result in problems. Means, let's say when you do the correlation matrix, you see any pair of the correlation actually is more than 0.7. Means must be careful. Okay. Okay. Yeah. So here they mention more than 0.7, actually including more than, including, actually that is R, okay, not like this. Yeah, means R more than 0.7 means you should suspect. You suspect maybe there is a multi-collinearity. If R is smaller than negative 0.7, you should also suspect maybe there is a problem of the multi-collinearity. Maybe. Okay, because remember this thing, yeah. A quick review on what you learn in stat. Okay, so yeah. Okay, let's say this. Okay, correlation is minimum negative 1, maximum positive 1. Let's say more than the correlation is more than 0.7. Let's say this area. You need that the relationship between the two variables is quite strong, positive. But let's say this area also strong relationship between the two variables, but negative. It means inverse relationship like this. One increase, another one drop. If positive means both increase or both drop. Okay, so therefore be careful here. Refer to more than 0.7. Also refer to less than negative 0.7. Okay. Over. Okay. Okay, now continue. Yeah. So, okay. So values much lower than the suggested threshold. Yeah, means let's say less than 10. Yeah, if much lower, only 3 to 5. Yeah, so may result interpretation or estimation problems. Yeah, okay. So particularly when the relationship with the dependent variables are weaker. Okay, so we need that if these two things happen, also must be very careful. Okay, so so first thing is that the VF is quite low, so should be good, should be good. But still, maybe this is a problem of the multi-cardinality. So when the relationship with the dependent are quite weak, meaning that the T is quite small value. Remember, if T is quite high, example T equals to 18, so we should reject the null hypothesis. Because when we reject the null hypothesis, means what? Means there is a strong relationship with the dependent variable. But let's say T is small. Example, let's say only 1.2, 1.25, example. Yeah, therefore it's small t. Small t, normally we cannot reject the null hypothesis. If we cannot reject the null hypothesis, what happens? Yeah, we cannot reject, meaning that it's weak relationship. You can see it's weak. Okay, no problem. I write down. Okay, so T small, let's say less than, I follow this example. Let's say it's equals to, yeah, equals to 1.25. T is equals to 18.2. Okay. So means there are two different two scenario. Is equals to 1.25. Yeah, means not able to, yeah, not able to reject the null hypothesis because too small. Remember, T small means P value is large. Yeah? So T is large, P value must be very small. Example 0.0015, small, very small. So we can reject the null hypothesis. Okay. If we cannot reject the null hypothesis, see the left side, left. Okay, left. Yeah. If we cannot reject the null hypothesis, meaning that the x1 or okay the independent variable not able to not affecting. Yeah, this simple. Yeah, not affecting the dependent variable. Okay. So for the right side, because we rejected the null hypothesis, yeah, therefore the independent variable affecting, yeah, affecting the dependent variable. Okay. So therefore the left side saying that weak relationship, okay, weak relationship with the dependent variable. Okay, so means we refer to this, refer to case one, yeah. Okay, this case two, we refer to case one to to discuss this point. Okay, so means when the VIF is quite small value, let's say 3 to 5, looks like good, but let's say at the same time, you see the report, the output, the T is quite small, 1.25. Means maybe also to suspect this problem, yeah, of the multi-continuity problem, maybe. Okay. Okay. Any question is? So anyone just join? Can mark attendance? Okay. So if now, okay. So means now we can make a decision already. Wait. Sorry, I didn't see. Oh, okay, this one done. Okay, wait. Okay. Wait, apa mah? Oh, okay. Okay, therefore, we can make decision now. Yeah. Okay. Okay. So therefore, we start starting tomorrow. Yeah, the weekday class we start at 7:30. Okay, 7:30 until 9:30. Okay, so still 2 hours. Okay. So okay. Okay, if no problem, so we come back for today. For today, we come back at 8. Yeah. So 8 until 9:30. Yeah. Yeah. Another 90 minutes. We'll see you at 8 p.m. Yeah. So for another 90 minutes. Okay. So okay. But sorry, one more thing. Once you come back, you stand by is the SPSS. We're going to see SPSS after the dinner break. Okay. Yeah. So thank you. See you. Yeah.